Hello everyone. I welcome you all to PamTen's YouTube channel. So if you're someone who is new to data structures algorithms or new to Python, if you're learning Python for data science applications, the first thing that you'd need to know is how to search from a given data structure or data space, because finding a given element or a target element from a data structure is extremely important. And this is where you have two searching algorithms which go by the name of linear search and binary search. So we'll be looking at these two algorithms in today's video. So let's go to Google Colab and start writing our code. I've opened up Google Colab and we'll take an array or a list. I'll call this as nums and I'll store some values inside this. Let me call them as 10, 20, 30, 40, and 50. So this is an array or a list, and I've stored this in a new object called as nums. I have all of these numbers. Now, what I want to do is, let's say I'd want to get the index of the element 30. That is, I'd want to find out at which index position is this particular element present. Well, if I actually manually count it, so this is index 0, index 1, and index 2. So element 30 is present at index 2. Now that is what I'd want to find with the help of the linear search algorithm. So I'll go ahead and create this method. I'll call this as lin search, and this will take in two parameters. The first parameter will be the array or the list through which we'll be iterating. And then I'll have another parameter called the target. This is the element for which we need to find out the index. Okay. Now, what we have to do is we'd have to iterate through the entire loop or the entire array. So I'll write down for I in range of length of nums. So here I'm getting the length of this array. So the length of the array will be 5, and this range method will go from 0 till 4 because 5 is exclusive. So i's value will be 0, 1, 2, 3, and 4. And now that I'm iterating through this entire list, what I'd want to do is I would want to check if this particular element is equal to the target value. So at each iteration, I'm checking if nums of I is equal to the target. And if that is the case, I'll just go ahead and return this particular index. That is it. And if that element is not present, I'll go ahead and return -1. Let's run this and see if this works properly. Lin search, nums is my array. And after this, let's say I'd want to find out the index at which element 30 is present. I'll give in 30 over here, and this returns me 2. So 0, 1, and 2, which is correct. Let me give in the value 50, and let's see what I get. 4, 0, 1, 2, 3, and 4. Let me check this with the element 10. This is present at index 0. Let me try something different. I'll give in the element 100 and let's see what do we get. We get -1 because this element is not present. So what is happening over here is we iterate through this entire list. Initially, I value is 0. So we check if nums of 0 is equal to target. So initially, our target was 30. So we are checking if 10 is equal to 30. No, that is false. Then we check if 20 is equal to 30. False. Then we check if 30 is equal to 30, which evaluates to true. And then we return the index of it. Now, if we iterate through the entire loop, and if we come out of the loop, that would mean that this particular element is not present in the list. And if it is not present in the list, we finally return -1. So this is how linear search works. Now we'll look at the time complexity of this algorithm. So the time complexity of this algorithm would be order of n. Now what does that mean? I'll just write it down over here, order of n. This would mean that I would have to iterate through this entire array or all of the n elements at the worst case so that I can get the result. So let's say if my element is 50, then this would be the worst case. I'd have to iterate through all of the n elements. Is it present here? No. Is it present here? No. Similarly, I'd have to traverse this entire list. So right now we have only 5 elements, but consider a case where you have maybe 1,000 elements in the array, and that particular element is present in the last position. Well, you would have to travel all of the 999 elements, and then you'll finally get the element at the last position. So this is why you'll say that the time complexity for linear search is order of n. Now, this is one search algorithm. Then we have something called as a binary search. And before we start with binary search, you have to understand something really important about binary search. So this algorithm only works when your array is sorted in place. That is, this array over here is sorted. The elements start from 10 and go till 50. Now, if the array were not sorted, you cannot use this algorithm. So let me go ahead, and what I'll do is I'll add a comment and write in binary search. Now let me take in a different array. So I'll call this, let's say, bin nums, and inside this I'll have the values from 100 to 500. So this is the new array, and again, the problem statement is similar. So I'd want to find out the index of a given element. So let's take 400 this time. So if 400 were the element, the target element, I need to find out the index for this target element. I'll go ahead and create a method. I'll give this a name of bin search. Now, this again takes in two parameters. The first parameter would be the array. Now, again, this, what you're passing in is the local parameter, right? So you'll pass something inside this and that'll be stored in nums. And now, again, I will need a target variable. Then I'll have two variables inside this. I'll set the low value to be 0 and I'll set the high value to be the index at the last position. So I'll have length of what I'm passing in is nums. So length of nums minus 1, right? So here, let's say if this is the array. So for this, the length will be 1, 2, 3, 4, and 5. And the index of the last element will be 5 minus 1, which is 4. So low is set to 0 and high is set to over here at the last element, which is 4. What this is called is as a two-pointer approach. I'm taking the low pointer and setting it at the initial position. I'm taking the high pointer and I'm setting it at the last position. I'm using two pointers so that I can traverse to this array. Okay, I have these set. Now I'll use a while loop, and through this while loop, I'll keep checking if low is less than or equal to high. Okay. Then at each iteration, I'd have to find out the middle value in this array. How do you find that? Well, I just need to type in low plus high by 2. And now, just to make sure that there are no calculation errors, we can actually type this as low plus of high minus low by 2. Now, if you do the calculation properly, this will be 2 times of low plus of high minus low by 2, which will be same as high plus low by 2. Okay, we've calculated the middle value. This is not completely done. Now, we need to check if the middle value is equal to the target. Okay, let's do that. So, if nums of mid is equal to target, what do? We go ahead and send the middle value or the index of the middle value. Okay, initially I have low at 100, high at 500. Now the middle value will be 300, but what I want to find is my target value is 400. So here 0 plus 4 by 2 will be 2. So 0, 1 and 2, this is the middle value, and I'm checking if this is the target. If this is the target, then return mid. Okay, this is fine, but this is where your actual binary search algorithm starts. What if your middle value is not equal to target? This is where you cut down your search space. So you check, is the element present on the left side of middle or is the element present on the right side of middle? If the element is not present on the left, then you completely eliminate your left side. Similarly, if your element is not present on the right side, you'll completely eliminate the right side. So you're cutting in half. And this is why binary search is a much more efficient algorithm when compared to linear search. But you have to remember that binary search only works when your array is sorted. Okay, so if array of mid, so if this the middle element is equal to the target, we return the index of the middle element. If that is not the case, elif, now I want to see if target is actually greater than the middle element, which is actually what we want, right? So here target is 400. Is this greater than the middle element? Yes. So if target is greater than the middle element, this will be nums of mid. What do I need to do? I need to eliminate the left space. So if I have to eliminate the left space, initially low was over here. So I'll get the low to the next place after mid. So low is here, high is here, mid is here. What I'll do is I'll take the low pointer and I'll set it to be here. So I'm cutting down the entire left space. Okay. What do I do? Low is equal to mid plus 1. Now, similarly, if that is not the case, so either this over here has to be equal to mid, or it has to be present on the right side, or it has to be present on the left side. So if it is present on the left side, what do? I take the high pointer and I set it to be at the left position of mid. So I'm removing the entire right side of this array. Okay, what do? High is equal to mid minus 1. Now this is also set. Then going ahead, this let me take care of the indentation properly. So all of my major concept for this binary search algorithm is set. If this is where the element is present, I return the index. If it is present on the left side, I eliminate the right side. If it is present on the right side, I eliminate the left side. Okay, since it is on the right side now, what do? I take the low and I set it to be here. So low is at 400, high is at 500. So this is 3 plus 4 by 2, 7 by 2. You need the integer value, so you get 3. So 0, 1, 2, 3. So 3 is what is present in your middle value. Then again, you come over here and then you check if nums of mid is equal to target. Is nums of 3 equal to target? 400. Yes, that is true. And that is why we return mid and this will return 3. Okay, let me run this. Let's see if this actually works. Bin search. Now the name of the array is bin nums is what I'm sending inside this, and the target will be 400, and this returns 3. But what if this is actually not present? Then what do we send? If the number is not present inside this list, again, I'll just go ahead and send -1. Let me change it to be 900 and let's have a look at the result. See, we get -1 because what happens is when the low becomes more than high, that is when the low pointer crosses the high pointer, we will exit the loop. And for all of the iteration, if we have not found the target element, we'll just go ahead and return -1. Now for this, let's understand the time complexity. So for this, the time complexity will be log of n because at each step we are dividing the array into half, right? And iteratively, when we divide the array in half, we are basically using the log of time n, not n. And that is why your logarithmic approach is better than your traversing the array sequentially. So binary search is much better when compared to your linear search. So friends, this is what we learned in today's session. We've learned about how to search through an array, and there were two important searching algorithms, which were linear search and binary search. So thank you very much. If you liked the video, do hit the like button, share this video with your friends, and do not forget to subscribe to our channel. Thank you, and I'll meet you in the next one.